Hey everybody, this is Larry. This is me going over Q3 of the recent Leetcode weekly contest, maximum score from performing multiplication operations. So I recommend you to hit the like button, hit the subscribe button, join me on Discord, ask me about disk problems, other problems, whatever you like. We could talk about, anything in general. But yeah. So just to, this one I struggled a lot during the contest. So let's take a look. I have 3 time limited and 2 wrong answers. The 2 wrong answers I was just being careless, but the time limit, at least this one, I'm gonna go over. So I'm gonna go over 2 solutions. Short answer is gonna be dynamic programming, but I'm gonna go over why. And the reason why I hate this problem is because the reason why I'm a little bit annoyed for this problem is because there's some a lot of the optimizations that I did were just constant operations. So I had the overall complexity correct. Anyway, we'll go over it in a second. But yeah, so that's basically the idea. The key thing to note is that you look at the constraint, which is the first thing I do. After you read the problem, is that m is 1,000 and n could be 10 to the 5th. But one thing to note is that if you only take stuff from the beginning and to the end, it doesn't matter how big the numbers array is, because you can only go m deep, right? Because even if nums was 1,000,000 elements, you're only going to use either the first 1,000 m or the last 1,000 m, right? So in that case, it is going to be m squared in the complexity. So from that, it becomes a simple, quote unquote, simple dynamic programming problem. If it was so simple, I wouldn't have, been here talking to you about 5 wrong answers. I wrote this bottoms up, but I'm going to go over, so the only thing that I changed was writing it from tops down to bottoms up. So there is some performance penalty because there is going to be some performance penalty because there is overhead with the recursive stack and stuff like that. But that said, it's still an annoying gotcha, especially because as I always say on Leetcode, the reason why these things TLE in Leetcode and why there's uncertainty about it is because for each input, so things time limit in Leetcode as a result of the sum, which is the total time that your code takes over all inputs, right? So that means that it may work for every individual input, but it might not work for all inputs together. And of course, they don't tell you the number of test cases. So, if we get 1 test case, it may work. We've got 10 test cases, it may work. But if you have 1,000 test cases, it may not work fast enough. And you have no way of knowing how many test cases there are. Okay, so rant aside, this is the top-down code, which is equivalent to my bottoms-up code. It has the same complexity, but we're going to go over. I can't edit it, so let's see. Let me click on edit code. So we'll go over it together. I think every time I do edit code, it doesn't actually do it correctly. So yeah, I'm gonna just paste this here for a sec. So the idea is, okay, now we just do a typical dynamic programming thing of, okay, so now we look at the multipliers one at a time, which is m, and for each multiplier we choose in a brute force kind of way whether we take one from the left or we take one from the right, and this is basically the recurrence, and you may note that if we took I numbers, then left plus right is equal to I, right? Roughly. That means that we took the number of numbers we took from left plus the number of numbers we took from right is equal to I. And of course, the numbers that we took from left is just left, the index, and the numbers that we took from right, we just count from the right side, which is this thing, n minus I plus left minus 1. You could do some math, you could draw it out. I'll leave that as an exercise for you to do at home. Some people may draw it out, but this is just arithmetic, so I'm not going to spend that much time on it. And then after that, we just choose the best, right? And the best is simply you go from the left side. So we take a number from the left, meaning, okay, you increment the index for the multiplier, you increment the left, and then you just take this, which is defined in the problem. You get the score from the left times the multiplier to the right, or you just get the multiplier. And this is the same thing, except for now, left remains the same because we only move to right. So there's an implicit thing here. You can also do it like this, and this would have the same complexity because left and right are totally dependent on each other. But in terms of space storage, this just is slightly efficient, and at least in Python it's going to be slightly faster. In this case, not fast enough in either case, but yeah. So here, we take a number from the right index, and this is the score you get from taking that number from the right. And then we just return the best, you cache the results, and that's all you have to do. And as we see, I goes from 0 to m, left goes from also 0 to m. So that means that this is going to be O of m squared. This is going to be O of m squared total number of possible cores, and each core will take over 1 time. So this is also the total time, and also total space, because for each input you can each possible input you do over 1 extra space. So basically this is the top-down version. I tried various way of optimizing this, but I just couldn't get it to work until I was like, oh, I guess I could do it bottoms up, but there's no guarantee that bottoms up would be fast enough, right? So that's basically, I tried other optimization first. I even tried doing it in C++, but it wasn't fast enough. But I did in C++ tops down, so maybe I could have done it bottoms up with C++, but it's just a really dubious thing in general. It's just a dubious thing or like, I have no way of knowing that if I wrote this bottoms up that this would be right, because it could just be that it is too slow, right? But this code I'm not gonna go over too much. If you have the other code that I just had, which is this, so you could pause for whatever. So this code is gonna be my code, and it's essentially the same code. So yeah. So, and I ate a WA, a wrong answer, because I had had the incorrect base case because I was silly. But yeah, this is just the bottom up version of that. And one cool thing to note though is that this is actually O of m squared, time and space. But if you can optimize this to be O of m space. And I'm not going to explain this too much, but the thing to note is that you'll ever, if you look at dp sub I in this array call, we only ever use dp sub I and dp sub I plus 1. So from that, you can reduce space that way. I have a video about dynamic programming and how to make that space optimization, so I'll put a link somewhere in the comments. Check that out. That's all I have for this problem. This is my usual rant, and you could watch me solve a live dinner contest next. If this time's out, I would be very sad, but I should have gotten it. It's me being dumb. Should have gotten it earlier. Okay. Nums. Exactly, enumerations. Any mods? No. If it TLEs, I'll be sad because they should be n square, m square. Oh no. That's weird. N doesn't really come into it. So this is, I don't know why this doesn't work. And this seems pretty straightforward as a DP. I don't want to optimize it more than I have to. That's not great though. I don't get it. I can only be up to M and M is only 1,000. So I think it's just another Python situation. If this is just silly. I'm a little bit sad about this now. Let me test the warning time. I mean, it takes a second, but this is n square, so I don't know that you can do better. actually don't know how to do a hash table in Java. Maybe I'll do it in C++. Still takes about the same time, so I don't get it. Is there a better solution? Maybe there is a better solution than n square. No, but m square is pretty fast. This is also TLU, then I'll be a little bit sad, but so this is actually time limit even faster. I don't get this one then, maybe. Maybe there's a greedy solution. I feel like n square should be fast enough, so I'm a little bit sad about this. Let me copy to my test cases. Why is my running time faster than before? By like a lot. Okay, now it's slow again. It's m square. So what can I optimize, right? I don't get this. but a lot of people have gotten it, so I'm just a little bit confused what optimization I can do. Is it just luck? Because there's literally a lot of fluctuation in running time. Right. I didn't change the code. This is ridiculous. Good job on, you know, but I have to get this one. I don't know why this isn't working. I've index. People got this one relatively quickly, so there's that. I just don't know how to do it. I mean, I guess there's some sort of greedy, but let's see. I mean, we don't even need most of these things. Does that matter? It is still m squared though. I don't get it. I don't get it. I don't. Huh. I don't know. This doesn't make sense what I'm trying to do. I mean, I'm gonna get such a. I'm gonna get such a high penalty too because I have so many thingy on this one, but my computer's a little bit slow. do this and then log in? Am I doing this wrong? I don't think so. Yeah, because for I, we can choose left or right. So why is m squared too slow? How many times have I submitted? And one of the times were dumb, but this one was a dumb one. But a lot of people have gotten this one. I don't get it though. Can I use this? I don't think greedy works. I mean, DP is a little bit harder on this one. Maybe? Like bottoms up. Maybe that's what I needed to do. Yeah, I mean, maybe that's what I needed to do is DP. But it's still a little bit sad that I have to convert it. I just wasn't thinking. Okay, let's see if I could do it that way. So what's my running time? I mean, the running time's not going to show. Oh, I don't know how this compiles, but okay. I have to get my indexes right. let's do push. Yeah, I get a little bit confused sometimes about pull. Which list is it talking about? This way. Why is this wrong? So, six. What am I doing wrong? Why is this going at one time error? This index out. But why is 0? I don't even know. So it's multiplier sub I. Oh, this is M. I am Dumbo. I am Dumbo. Confused it. I mean, this isn't even that much faster, and it's also wrong, but that's besides the point. I might have just missed this one, actually. It is definitely faster, but it's still wrong. Okay. So what? We have an off by 1 somewhere. I think that's the right answer, but it's still pretty slow, so I'm a little bit worried. But I mean, at this point, I don't know, right? bit. Why is m squared not fast enough? I don't get it. Oh, well, now I have a wrong answer, which is different. I messed up right enough. I don't think so, but yeah, I don't think so. What am I getting wrong then? I mean, it just stops printing. I think there's more, but so what is the answer? Expect is 304,000. Where am I getting this? They should really have two answers from the left and the right, so I'm off by something here. Unless there's a 0 in the answer now. So 83 should be definitely wrong. Oops. 83. So it's 70,000. So this is not that. What's the last number? 130. So that's it, only this number. Where did the other number go? Yeah, that looks right. Actually. This is choosing the right and the left. Why is this not set? Did I reset it somewhere? I guess I reset it somewhere by accident, but oh, because the default is 0. Okay, well that's a little bit different, but because the best answer could be negative. Okay. Okay, I am being dumb. $14,102, let's go. Please don't TLE. then maybe it's some greedy that I don't know how to do. Yeah, so thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other problems, and I'll see you later. Bye bye. Also, take care.